Today's homework, starting with question 13, we're asked to prove that a4 plus b4 is greater than or equal to 2a squared b squared. So what we'll do is we'll bring that 2a squared b squared to the opposite side. We get a minus, and we're hoping to prove it's greater than or equal to 0. The square root of a4 is a squared and b4 is b squared, and that will be a squared minus b squared, all to be squared. I'm missing the square there, but that is greater than or equal to 0. So that's true, so therefore the original statement that we're asked to prove is also true. In question 14, if a and b are positive numbers, try and prove that. Well, I'm going to start by multiplying out the left side of the inequality there. And when I do that, I get cancellation. I get 1 there, and the two b's will cancel to give me 1. And I'll be left with a over 2b plus 2b over a will be greater than or equal to 2. That's because I brought the 1 and 1 to the opposite side and make them minus. So what I'm then going to do is going to combine the two fractions on the left there to give me 2ab as the denominator. And when I do so, I'll get a squared plus 4b squared is greater than or equal to 2. I'm going to multiply across by 2ab now, and the inequality sign will be preserved because a and b are positive numbers. That'll give me 4ab on the right hand side. Bring that then to the left, so a squared minus 4ab plus 4b squared is greater than or equal to 0. Is that true? Well, it is, because a minus 2b squared is greater than or equal to 0. That's what that is. Therefore, that statement is true. So therefore, if we go back to the original statement, the original inequality, that therefore is also true. Okay, and there it is there. In question 15, very similar. We have a over a plus 1 ought to be squared. It's less than 1/4. We're asked to prove this. I'm going to multiply across by a plus 1 to be squared. When I get that, I get the following. The inequality sign doesn't change. I'm multiplying by a positive number. Then multiply across by 4, and I end up with 4a is less than a plus 1 squared. Switch that around. Switch the inequality sign as you're doing it. Remove the brackets. I get a squared plus 2a plus 1 will be greater than 4a. Bring the 4a to the opposite side. I get a squared minus 2a plus 1 will be greater than 0. Is that true? Well, it is, because that's equal to a minus 1 squared is greater than 0, and anything squared is, of course, positive, will be greater than 0. That's true, so therefore the original statement that we're asked to prove, the original inequality we're asked to prove, is also true. In question 16, it's a bit of a long-winded question. We sort of started this morning. We have a4 minus b4. Well, that will be equal to a squared minus b squared by a squared plus b squared. Okay, that's the answer to part A. There's 2 factors, and there's 3 factors. That would be equal to a squared plus b squared times a plus b by a minus b, because a squared minus b squared is equal to a plus b by a minus b. We're then asked to factorize a5 minus a4b. We'll take the first 2 terms, we're going to do it in a moment, and then take the last 2 terms and factorize them separately. If I take the first 2 terms, I take out a4, I get a minus b, and if I take the last 2 terms, it's minus b4, take out a minus b. Combine these into 2 factors, you'll get a4 minus b4 times a minus b. Well, I've already worked out what a4 minus b4 is. There it is above. So there we go. We're going to replace a4 minus b4 with a squared plus b squared by a plus b and a minus b, and that'll give me a squared plus b squared by a minus b squared all times a plus b. In the last part, I'm asked to prove that a5 plus b5 is greater than a4b plus ab4. Well, I've just worked that out a moment ago. If I bring the a4b and the ab4 to the left hand side, I'm just rewriting out the full inequality here. If I bring the a4b and the ab4 to the left hand side, I get a5 plus b5 minus a4b minus ab4. I have to prove that that's greater than 0. Well, I've worked out the inequality there. I've factorized that already, that left hand side. There it is there in the second part. So I'm going to replace that with a squared plus b squared all times a minus b all to be squared times a plus b. Well, is that all greater than 0? Well, a squared plus b squared is definitely positive because they're both squared in that factor there. So I'm just looking at my first, that's definitely positive. A minus b squared is definitely positive because I'm squaring. And a plus b is also positive. How do I know that? Because the question tells me that a and b are both positive unequal numbers. Okay, so they're both positive. So therefore that entire expression is positive. If that's the case, and it is the case, that will therefore tell me that the original statement I was asked to prove is true. In question 18, prove that the square root of AB is greater than 2AB over a plus b, well, let's square both sides. When we do that, we get ab is greater than 4a squared b squared all over a plus b squared. And I'm going to multiply across by a plus b squared. That'll retain the inequality sign when I do that. Now I'm going to divide by ab. I get a plus b squared, a ought to be squared, would be greater than 4ab. I'm going to work out the left hand side there. I'm going to bring the 4ab to the opposite side, that's greater than 0. I get a squared minus 2ab plus b squared would be greater than 0. Is that all greater than 0? It is, because it's a minus b ought to be squared, it's greater than 0. Again, that's true, has to be true. The original statement we're asked to prove is therefore also true. And in the last question, question 19, I'm asked to prove that a plus a over a plus 2 is greater than or equal to 4. Again, this is similar. Combine the left hand side into one fraction. You're going to end up with a squared plus 2a plus a is greater than or equal to 4. I'm going to multiply across by a plus 2. I can do that because I'm told that a plus 2 is positive, is greater than 0. So I'll end up with 4a plus 8 on the right hand side. I'm going to bring everything to the left hand side. I'll end up with I'm just saying that the inequality sign is preserved because a plus 2 is positive. I'm going to bring everything to the left hand side. I get a squared minus 2a plus 1 is greater than or equal to 0. Is that true? Well, it is. Why? Because a minus 1 squared is equal to that. And so therefore that is true. If that's true, the original statement we're asked to prove is also going to be true.